Hi, welcome to the 2011 Harriet Bishop Science Fair video on judging projects in the scientific method. This video was developed for science fair judges, but parents and students are welcome to view it as well. If you've judged the science fair before, we've changed a few components of judging, so we hope you'll still take time to review this video. In the video, we're going to review how to use the scoring sheet to judge projects, as well as cover some basics of the scientific method. We'll provide more information on the overall process at the judging orientation the morning of the fair. We recommend you have the handouts provided via email with you as you review the video. These include the judging form, an overview of the scientific method, and an overview of a controlled experiment. First, the top section of the judging form. This section contains basic information about the project you are judging. When you receive the scoring sheets for the projects on the morning of the fair, the students' names and project number will already be listed, and you'll be asked to fill in your judge number, which you'll be provided with the morning of the fair. This section of the scoring sheet is also where the total score for the project is entered by judges after judging is completed. The most significant change from previous science fairs is that this year, students are allowed to create the project with a partner. Keep in mind that your approach to judging the project should be the same whether there are one or two students doing a project. The only real difference for judges is that in conducting the interviews with students, you may have various levels of response from those projects with two students. Where the project does have two students, you should not judge students individually, but rather on their feedback and answers given as a team. For example, in one case, one member of the team may provide all the answers. In another, both team members might provide feedback. In both cases, judging should be based on the overall quality of the feedback given as a team, not separately for each student. The next section of the scoring sheet is required items. Each project must have each of these items, so as a judge, simply check the box if the project contains the item. If not, leave the box blank. It often helps to check for these items when you get to preview the project before the judging starts with the students. It will give you more time to spend with the students during the interview. Each item is worth 1 point, so add up the check boxes and enter the total at the right. For the presentation section and the remaining scoring sections, judges will use a 5-point scale. 1 for unsatisfactory, 2 for needs improvement, 3 for satisfactory, 4 for good, and 5 for excellent. Before we talk about the presentation items, let's talk about the point scale. As with last year, we have a 5-point scale that matches the scoring method at the state science fair level. Judges are encouraged to approach projects from the middle of the scale, assuming that a given project is a 3 or satisfactory. Then, based on the criteria, they can award a score as follows. Elements that are better than satisfactory could be given a 4. Elements that are excellent and go above and beyond could be given a 5, though this would be awarded on only a few cases. On the other hand, elements that are slightly less than satisfactory and could use some improvement could be given a 2. Elements that are unsatisfactory or absent could be given a 1. Again, this will likely be awarded in only a few cases. Remember to be fair and honest with your judging. The students do not see the scores, and it's important that the best projects are clearly identified through the judging process. Also remember that students are not graded on their projects. Now, let's talk about the presentation elements. Judges are welcome to make these scores during the preview time. These elements are related specifically to the project display in the accompanying notebook. For example, note the final element, attention to spelling. A project with no typos and excellent or perfect grammar might get a 5. A project with just one typo but excellent grammar might get a 4. A project with a few typos and/or a few grammar issues would get a 3. A project with a number of typos and poor grammar would get a 2. And a project full of typos and lacking grammar might get a 1. Don't worry about memorizing that example. It's just to demonstrate how to apply the 5-point scale. In each case, use your judgment about what score to give. With each scoring section, add all the individual element scores to create a total, enter it at the right. In this section, judges will evaluate how well the student followed the scientific method in their project. It's important to note that there are many different kinds of projects students will create. But keep in mind the science fair guidelines call for students to apply the scientific method, and those projects that are selected for advancement to Mankato will best adhere to this approach. We strongly encourage judges to review the sheet that outlines the elements of the scientific method, as well as the sheet on controlled experiments to reacquaint themselves. As with the previous section, judges use the same 1 through 5 scale. For each of the 9 elements, use your best judgment to assign a score. For each, we've tried to provide some guiding criteria to help you assign a score. For example, note the element statement of the problem. Consider, is the problem stated as a question? Is it clear? Does it try to account for just one variable? Is it an original question? A project that covers all of these criteria and more in a strong way could receive a 5. 5. A project that represents a true statement of the problem but is lacking in 1 or 2 other criteria could receive a 4. A project that is a true statement of the problem but lacks all other aspects could receive a 3. A project that isn't a true statement of the problem, for example, it might try to account for more than one variable, but has other positive aspects, could receive a 2. A project that is not a true statement of the problem and has no other positive aspects could receive a 1. The last element gives you the opportunity to reward a project that has covered all elements in a strong or positive way. Note that the most common challenges for students are setting a control group or focusing on the impact of just one variable. Here are 3 examples to help demonstrate how different projects might apply the scientific method. First, a great example of an experiment that follows the scientific method would start with a statement of the problem such as, how does the amount of fertilizer used affect plant growth? The test variable will be the amount of fertilizer used, so all other variables and conditions must stay the same. The control group would be a plant with no fertilizer. In this case, a poorly constructed experiment might ask, how does the amount of fertilizer used impact plant growth and its lifespan? Or, how does the amount of fertilizer and water used impact plant growth? In the next example, suppose a student wanted to see the impact of the size of wheels on the speed of a car, using a model car. Again, there's one variable, the size of wheels, and one result being measured, the speed of the car. In this case, the control group isn't obvious. You can't use a car with no wheels. However, the student could pick almost any size wheel, then vary the wheel size either up or down in the experiment. This again would be an acceptable application of the scientific method. Finally, consider a project that sought to determine which brand of paper towel was the most absorbent. There is one result being measured, absorbency, but the rest of the experiment doesn't follow the scientific method. For example, a student could arbitrarily select a control group, say Bounty paper towels. But then, what is the one variable being changed? The name of the paper towel, Target or Walmart or Bounty, has no impact on absorbency. If the student found the Target brand was the most absorbent, how would they explain that? There could be many reasons: type of paper used in the paper towel, how it was manufactured, the thickness of the paper, etc. Because they didn't isolate just one variable, there's no way to know what is impacting the different levels of absorbency. In this example, the project scores related to scientific method would need to be lower. The final section is based on the interview with the student or students. The elements listed should provide a good guide for questions to ask. For example, to judge the first element, a judge might ask, describe how you went about creating your experiment. Of course, judges are encouraged to ask whatever questions they feel are warranted. Note that we've added a new question related to whether the work was done by the student themselves. Sometimes this can be difficult to ascertain, though it's certainly acceptable to ask students, did you have help? More importantly, you can use your opinion based on how well the students are able to answer questions overall in the interview to help determine how much help they may have had. If a student struggles to explain how they conducted the experiment or what they learned from it, it's often a sign that they didn't do the majority of the work. If you're not sure, don't penalize the student, but keep the score given on this question or this element in the middle range. This is a good time to provide a judging tip. It helps to complete judging forms for each project during the interview process or right away. That way, it's easier to remember the interview dialogue and the project itself before you move to the next project. Remember that some students are less comfortable with the interview portion of the judging process. Sometimes it helps to kneel or sit on the chair to be at their eye level. With some students, you may have to work a little harder to draw out the information you need, but just remember to be patient. The final portion of the judging form allows for judges to provide feedback to students on what was strong about their project and what they may need to work on. It's very important to provide feedback here, as this is the only portion of the judging scoring sheet students will see. So it's the only feedback they can use to learn from the process and improve their project next time, or to compete better at the state level. While students need honest feedback, please be constructive in your comments. If you're confused on what to write, here's a tip. For the section on what the student did well, review your scoring sheet and provide reinforcement of one or more of the scoring areas where the student received a higher score. For improvement, provide more insight into areas where the student might have received a lower score. And again, keep in mind to provide comments based on the overall team effort, not individual students. Well, that's it. As always, we appreciate the time you've given as a volunteer. The Harriet Bishop Science Fair could not happen without you. If you have any questions, please don't hesitate to contact me via email. Thanks for your time.